Hi, so I'm going to be redoing weekly review question 2. So the two questions that I need to redo is the last step of the nucleotide excision repair, kind of briefly go over that again. And then question number 2 is MDA cell, what the outcome of MDA cells if it was hit by UV. So first for nucleotide excision repair, like we said in the last video, it's similar to mismatch repair. So what's going to happen is, say we have a sequence here, and just making one up. So say we have a sequence here, and it was hit by UV. So then that's going to form a thymine dimer, because it's going to cause cell damage. So say right here, we have a thymine dimer that forms right here. So that is not good because that's mutation. So we need to get rid of that. And so what's going to happen is that the cell is going to recognize that there's damage, and they're going to make an excision. So nucleotide excision repair, right there, to cut out the bad nucleotide. So they're going to cut out a little before and a little after. Just like that. And that is, so nuclease is going to recognize that there's an issue here, and then helicase is going to cut it out. So it's going to be resynthesized, and DNA polymerase is going to come in, and it's going to repair and put fresh new DNA nucleotides here. And then we don't have a cut. And ligase is going to seal, and then it can transcribe and lay on its way. So everything will be dead. But say we have extensive, so we have like multiple thymine dimers that form. So that would indicate that cell death would most likely occur, apoptosis, because there are so many thymine dimers that are formed. It's hard for the cell to replace them all, because you would have to make cut like here, here, here. You're just cutting the whole strand at that point, the whole strand. So it just be better for the cell to go through apoptosis at that point. And when this happens, p53 levels are going to increase and slow the cell cycle, so the cell and their enzymes can do this process. So now in an MDA cell, if it got hit with UV, so our MDA cells lack p53. So they don't have p53 in them, which is it's a big factor here. And so like our mammary cells or some other cancer cells that have p53, we'd go through the process that we did in the other video, or nucleotide excision repair. But since p53 lacks, it can't slow the cells, it can't increase, recognize damage, slow the cell cycle, all of that. And so what would happen if we have our strands here, and say we had thymine dimers here and here, what's going to happen is the cell is just going to go through its normal processes with the thymine dimers, and it's just going to create more, because it's going to keep replicating, so it's going to create more thymine dimers. So more thymine dimers are going to occur in newly synthesized strands, which is the whole aspect of cancer, because they're going to keep replicating with the mutation, which is bad, so they're bad cells, and they can't go through apoptosis because they don't have p53. so they can't go through cell death. So what would keep happening is they're just going to keep replicating with thymine dimers and get out of control and cause major cancer, basically. So that's the problem with our MDA cells, is that they can't go through cell death. They can't go through nucleotide repair because they lack p53. So they're just going to keep replicating, cause more mutations, just keep on going. So thank you.